So the term cancer was first coined by Hippocrates in 370 BC, and today it is 2018, which means that it has been 2,388 years since humanity has not been able to find a real viable cure for cancer. To put this into perspective, smallpox has been completely eradicated in 1977, and measles in livestock was eradicated in 2001. Even polio has only had 22 cases in 2017. And so, compared to all of those diseases, cancer today is still the world's second leading cause of death, with over 8.8 million deaths in 2015. And this is a problem that needs to be addressed as soon as possible. So as humans, we're on the verge of sending humans to Mars. So why are we still unable to prevent so many deaths from happening from a disease that has been documented for such a long period of time? So many common treatments for cancer that are used nowadays are radiation therapy and chemotherapy. However, both of these therapies have really low success rates, and they also have a lot of adverse side effects on the body of the patients. A newer, more emerging treatment for cancer is immunotherapy, and immunotherapy promises to pretty much leverage our body's natural immune responses to fight against cancer. It sounds really good, and there's been a lot of great progresses in immunotherapy, but there's also a lot of really negative side effects. For example, nonspecific immune stimulation is one of the types of treatment of immunotherapy, and one of the really adverse side effects is that your immune system actually starts eating away at your healthy cells. So we really want to be able to prevent that. So let's take a look closer at what actually happens on the cellular level when it comes to the immune system targeting tumors. So basically, cytotoxic T cells are really effective at killing tumor cells because once they are activated by dendritic cells, which are another type of cell in your immune system, they are able to actually puncture all of your tumor cells and kill them by inducing them into apoptosis. So they're really effective at doing this if they are not inhibited by another factor. The catch, though, is that tumor cells evolve and adapt much too fast for the immune system to keep up. And so what happens is a lot of solid-state tumors are developing a receptor, a protein called PD-L1 on the surface of their cell. And so this is really, really, really bad because PD-L1 is actually a receptor commonly used by dendritic cells and macrophages to stop T cells from eating away at your healthy cells in other parts of your body. So what this means is that now with the reaction between the PD-L1 receptor on the tumor cell and the programmed cell death receptor, the PD-1 receptor on the immune system cell, the T cell, the tumor is actually now able to fully suppress the immune response to the tumor. So this is really bad. And a couple of treatments that have popped up in immunotherapy to target this issue, we have a treatment which sends an antibody to actually act like a glove that covers the PD-1 receptor on the T cell. And so what this does is it's going to inhibit the reaction between the PD-1 and the PD-L1. And so in this way, the immune system and the T cells are going to actually be able to just continue and shrink the tumor until it eventually disappears. However, the catch with using pembrolizumab, which is the antibody that acts as a glove, is that the antibody eventually degrades over time. So the patient is going to end up needing higher dosages each and every time and more frequently. And this is really bad because it causes the dendritic cells and the macrophages to be unable to stop the T cells from eating away at your healthy cells in other parts of the body. So let's take a moment to think about this. It's 2018. Why are we taking such a preventative approach in immunotherapy when we can literally hack the DNA of the tumor cells with CRISPR-Cas9? So this is a gene editing tool that is so much more effective and so much faster than anything we've had access to before. And so using CRISPR-Cas9, we will actually be able to engineer the tumor cells so that they produce a protein, a molecule that will be able to destroy their own PD-L1 receptors so that the T cells will actually be able to continue the immune response and effectively destroy all of the tumor cells. And so this leads to the solution that AscenHealth is proposing. So our solution has three elements. So the first one is we really want to optimize drug delivery. So a common pitfall of many cancer treatments is that drug delivery is not targeted enough, it's not precise enough. And so because of that, it causes a lot of buildup, and it also makes the body of the patient much, much weaker. And this is really bad. So in order to counteract that, AscenHealth is going to employ nanoparticle carriers in order to transport the genetic treatment to the tumor cells. And this is much, much better than the status quo, because using liposomes, which are made out of the same material that the cellular membrane is made out of, the liposomes will actually be able to bind to the overexpressed antigens that commonly pop up on cancer cells. So it improves the targeting, makes everything much faster and much more precise. So you need less dosages, and furthermore, liposomes are also much more biocompatible and more permeable, and they will also help decrease the possibility of the patient becoming immune to reacting to the drug. And the last component is actually what we want the tumor cell to create to destroy its PD-L1 receptors. So it's a molecule called PROTAC, and what PROTAC is really good at doing is that it's really good at degrading proteins. So inside the cell, PROTAC is made out of two molecules that bind to proteins linked together. So what happens afterwards is that PROTAC is going to degrade the protein into smaller polypeptides or amino acids. So it's really effective at doing this. And so we're going to inject the PROTAC into liposomes, and afterwards that's going to be inject the genetic information that's going to help produce the PROTAC into the liposomes. And then after that, we're going to deliver that straight to the tumor cells. So why does all of this actually matter? Like, why is this so important? To give you a better perspective, I'm just going to show you a couple numbers of what it's like today. So chemotherapy right now has a 60% survival rate, which is really not that good. And immunotherapy has a 10% increase. And it also has really life-threatening side effects from autoimmune responses, because a lot of immunotherapy treatments actually boost your immune system, but it does it indiscriminately. However, the solution that AscenHealth is proposing is better at targeting the tumor. It diminishes the autoimmune response, and it also is a more sustainable treatment because it genetically engineers the tumor cells. So even if the T cells aren't able to get to that tumor cell in time and it divides, its daughter cells will still contain the genetic information that will allow it to destroy its own PD-L1 receptor. So in the United States alone, $5 billion have been invested into cancer research. And 4,000 people every single day in North America die from cancer. And by combining all of these exponential technologies like nano drug carriers and CRISPR-Cas9 and PROTAC, we want to change that number to 0. And we're going to need the best talent of the world in order to input this solution so that more people's lives can become better, and people won't have to worry about their loved ones having to suffer through cancer. And patients will actually be able to look forward to the next step in their lives. Thank you.